Hello class. Today we're going to be looking at a few more characteristics of our polynomial functions. We're going to look at where the zeros are and the multiplicity of those zeros, and combined with the other things that we've learned in the past about those characteristics of polynomial functions, we're going to be able to graph a sketch of those. So let's go ahead and get started. In our last unit, we were looking at quadratic functions, and we learned where those zeros were by a few different ways. We could either factor, sometimes we use the quadratic formula, or completing the square so that we could find those zeros and be able to graph the function more clearly. Now, this time we're going to be graphing things that are not quadrilaterals, but we're still going to refer to those skills. Now, this one's not a quadrilateral, but we can still factor that because it has a greatest common factor of x squared. X squared comes out and it's going to be x squared minus 4. Well, x squared minus 4 can be factored into x plus 2 and x minus 2. We still have that x squared there. Now, we're going to set each one of those factors equal 0. X squared equals 0. X plus 2 equals 0. And x minus 2 equals 0. So x squared divided by is equal to 0. The square root of x squared is x, and the square root of 0 is 0, whether it's positive or negative. And we're also going to have, when we subtract 2 from x plus 2 equals 0, we'll have x is equal to negative 2. And then when we add 2 to x minus 2, we'll have x also equal to 2. So our answer is x equals 0, negative 2, and 2. I have to wait for my pen to catch up. Do I have a 2 on there? All right, there we go. So in that last thing the last function that we factored, we had an x squared as one of the factors, and that gave us, when we set that to 0, x was a 0, but we had a multiplicity of 2, and we've never looked at that before. But the multiplicity refers to the number of times that factor occurs in the polynomial. So x occurs twice in the polynomial that we just did. Let's factor another one. Well, this one's already factored for us. We have two factors, x minus 1. We'll set that equal to 0. And then we also have x plus 3, which we'll set to 0. When we solve this, x minus 1 equals 0, we get x is equal to 1. And then we're going to state that it has a multiplicity of 2. I like to just go m2 because that's a long word. What that means then is that when it has an even one, it's going to be, or it occurs twice, and that means it's going to touch the graph and turn around. The x plus 3 gives us 0 of x equals negative 3, and that has a multiplicity of 3. Oops. Multiplicity of 3, which means it's going to cross the graph. But instead of just crossing straight up, that would be a multiplicity of 1. It's going to have a little curve to it to indicate that it's a little bit greater multiplicity than just 1. So I've already indicated on the previous slide what the odd and even multiplicities are going to mean. The odd multiplicities is going to cross the x-axis. And even ones, they're going to touch and turn. So something that's odd might go through like this. Something that's even, it's going to come down, touch it, and then bounce back. And as that multiplicity gets larger, it's going to flatten. So, for example, if I wanted something like x to the 8th, it's going to come down, get real flat. Now, there's only going to be one point that touches the graph, but it's going to look to the naked eye like several are. So let's look at this function. F of x equals 3 times x plus 1 squared times x minus 2. First thing we want to do is find the leading term, use that leading term test to determine the end behavior. Now the leading term, we're going to take the leading term of 3 in each factor, x squared and x. So our leading term is 3x cubed. The exponent is odd, and the leading coefficient is positive. So it's going to have this sort of behavior, and we'll state that as x approaches negative infinity, y approaches negative infinity, and as x approaches infinity, y approaches infinity. So we know it's going to look something like that. So our x-intercepts are when we're going to set each of these factors equal to 0. So we have x plus 1, and we'll set that equal to 0, and we find that x is equal to negative 1. That has a multiplicity of 2, which means it's going to touch and turn. So at negative 1, right there, it's going to touch the graph and turn around. If I take x minus 2 and set that equal to 0, I get x equals 2, and that has a multiplicity of 1. So it's going to cross the x-axis at this point right here. And those are the only times, and I know that this one is going to have to go down, this one is going to have to go up for my leading terms, and this one's going to turn around. So the y-intercept, that's when x is 0, so f of 0 equals 3 times 0 plus 1 squared times 0 minus 2. And you end up with 3 times 1 squared times negative 2. 1 squared is 1. 1 times 3 is 3. And 3 times negative 2 is negative 6. So we have a y-intercept right here. So this is going to come down, cross through there. There is no symmetry in this one. But let's find an additional point. Kind of want to know this f of 1. So I'm going to take 3 times, so that you can see it, 3 times 1 plus 1 squared times 1 minus 2. So we have 3, 1 plus 1 is 2, 2 squared is 4, and we're going to multiply that by negative 1. So that's going to be negative 12. That's pretty close to where it's going to fall. Somewhere around there when we come up. And that's a very good sketch of this function. As we're getting ready to graph this function, f of x equals 6x cubed minus 9x minus x to the 5th, I'm going to rewrite this so it's in standard form. So my leading coefficient is going to be negative x to the 5th. Then we'll have plus 6x cubed minus 9x. So my leading term is going to be negative x to the 5th. The exponent is odd, and the leading coefficient, negative 1, is negative. So I'll have the behavior that looks like this. And we say as x approaches negative infinity, y approaches infinity, and as x approaches infinity, y approaches negative infinity. Now we want to find the x-intercepts for this, and we're going to do that by factoring it. So I'm going to factor out first a negative x as a common factor. We get x to the 4th minus 6x squared plus 9. Yeah. Now this is quadratic in form, so I can factor that as negative x times x minus 3 x squared, minus 3 squared. So then I can set, we've got two factors here that will set equal to 0. Negative x equals 0. So x is equal to 0, and that's going to give us it has a multiplicity of 1, so it's going to cross at 0. And I have the factor x squared minus 3 is equal to 0. So I have x squared is equal to 3. And so if I take the square root, I get x is equal to positive or negative the square root of 3, which is approximately 1.73. And remember, it's plus or minus, and at each of those it's going to touch and turn because it has a multiplicity of 2. So at 1.73, negative 1.73, and at 173. The y-intercept is when f is f of 0. So f of 0, 6 times 0 minus 7 times 0 minus 0 is just 0. So it's a point we already have. There is symmetry on this. This is an odd function. So it has rotational symmetry about the origin. So I know this one is going to be going up. This one's going to be going down. And I know this is going to be crossing, but I don't know quite how far it's going to be going up or down. So let's just find like f of 1. So we're going to take 6 times 1 cubed minus 9 times 1 minus 1 to the 5th. Well, that's 6 minus 9 minus 5. Or I'm sorry, 1, not 5. 1. And so 6 minus 10, that's going to give us negative 4. So at 1, it's going to come all the way down to negative 4. And we're going to have a symmetrical point up here. So it's going to look like that.